Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at solving equations. So equations are expressions with an equal sign. We solve them, we're finding a value that we can substitute for the pronumeral, i.e. letter, to make this a true statement. And to do that, we follow the instructions here. So let's look at this equation. Our first job is to get x to one spot. This fraction here makes it hard, so what I'm going to do is get rid of the fraction. I do that by multiplying by 3. The way I undo dividing 3 is to times by 3. So what you do to one side, you must do to the other. Now, when I'm multiplying by 3, I must multiply each individual term by 3. So I multiply x by 3. When I multiply the fraction by 3, I get just the x plus 1, but I have to put it in brackets. I'm subtracting the whole thing, not just the x. On the right-hand side, I go 5 times 3 is 15. I want to get x into one spot, so what I'm going to do is expand the brackets. I'm going to distribute the minus to the x into the 1. So I get 3x minus 1 equals 15. And now I collect like terms. 3x minus x is just 2x. So first goal is now achieved. X is in one spot. Now what I do is undo what's been done to x in the opposite order to BIDMAS. It's like in the morning you put on your socks, then your shoes. At night you have to take off your shoes first because it's the last thing you put on. So here x was multiplied by 2 and then 1 was subtracted. 1 was subtracted last. It's the first thing I undo. I undo subtracting 1 by adding 1 to both sides. I get 2x is equal to 16. Now I undo timesing by 2 by dividing by 2. So the answer I get is x equals 8. This is the solution because if I substitute here and here, x for 8, I will get a true statement. All right, let's look at this one here. So what we're going to do first is expand the brackets because we want to get x into one spot. So 7 times 4 and 7 times negative x. And then on the right-hand side, 5 times 8 and 5 times negative x. Now, I still haven't got x into only one spot. The way I'm going to do that when x is on both sides of the equation is I am going to subtract from both sides the x with the lowest coefficient. The coefficient here, negative 7, is less than negative 5. So I'm going to subtract negative 7x from both sides. Of course, subtracting a negative is the same as adding. If I add 7x to this side, it will get rid of it. But what you do to one side, you must do to the other. So negative 7x plus 7x is just 0. I'm left with 28 on the left-hand side. Now remember, I can only add or subtract like terms. So I can't add 40 and 7x, but I can add negative 5x plus 7x. So I'm going to leave the 40 alone. Negative 5x plus 7x is 2x. So now I'm going to undo what's been done to x in the opposite order to BIDMAS. I'm going to subtract 40 from both sides and then divide each side by 2. So I end up with x equals negative 6. This is the solution because if I substitute here and here, I get a true statement. I get 7 times 10 equals 5 times 14. That's true. Let's now look at a worded problem. So let's solve this worded problem. My friend has 50, more than double the amount I have. We have 410 between us. How much does each of us have? So we're going to follow these steps here. The first step says define a variable. That means you let x be one of the things you're trying to find. So I'll let x be the amount of money I have, but I also need to write an expression for how much my friend has. But here, where it says using single pronumeral, that means I have to use x. I can't use y to define how much my friend has. We don't know how to solve equations with an x and a y. So I need to write how much my friend has in terms of x. So my friend has what I have doubled. So that's double my amount plus 50 more. So I've done step one. I've defined the two variables, the two unknowns in this question, using the same letter. So step two, I'm going to write an equation. I'm going to rewrite the words in the problem using only mathematical symbols. So the amount I have plus the amount my friend has is equal to 410. So now I've got an equation that I can solve just like I did on the previous slide. I need to get x to one spot. X plus 2x is 3x. So when I have x to one spot, all I need to do is undo what I've done to x in the opposite order to BIDMAS. So I'm going to subtract 50 from both sides and then divide each side by 3. So x equals 120. For these worded problems, I need to write a sentence about what I've found. So x was the amount I have. So I have $120 and my friend has 2 times 120 plus 50, $290. And once we've written this sentence to say what we found, we are done. All right, let's look at rearranging formula now. So we are looking at rearranging a formula or changing the subject of an equation. The subject of an equation is just the thing that's by itself in the equation. So in this equation, 4z is the subject of the equation. We're going to rearrange this equation so that it's y equals something. So to do that, I can just treat these non-y terms as I would normal numbers. So if I wanted to get rid of this on the left-hand side, I would just add it. So we're solving this just as we would a normal equation. So again, what I do to one side of the equation, I must do to the other. So the reason I did that, negative 3x plus 3x is just 0. It disappears. I'm left with 1 over y equals 4z plus 3x. Now, I want y by itself, not 1 over y. I can do whatever I want to this side as long as I do it to that side. What I really want to do here is flip this fraction to make it y over 1. So if I flip the fraction on the left-hand side, I have to flip the fraction on the right-hand side. So 4z plus 3x, I can just write it over 1 without changing it. So because I flipped the fraction here, I must flip the fraction here. So I get y over 1 equals 1 over 4z plus 3x. Of course, I don't really need to write the over 1 here, so I'm just going to rub that out, and I'm left with y equals 1 over 4z plus 3x. Now I have an equation where y is the subject, so I've completed the question. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.